Here's your overarching learning goal that we've talked about already. You should feel comfortable defining basic terms like matter, mass, chemistry. That's what you'll see on the quiz. Converting and calculating quantities, simple conversions like 1 gram is 1,000 milligrams, or more complex conversions, for example, from molecules to liters, things like that. We want to be able to express quantities in the correct number of sig figs, and that's what we're going to be doing today. We're going to learn our rules of significant digits and then how to express answers appropriately. And you'll see how to round appropriately too. A little different than what you learned in math previously. And later on we'll be classifying matter and discussing properties and changes therein. We're going to move in our notes slightly a little bit out of order. And as I said, this lesson can be a little bit tricky. We had finished off with conversions. I'm going to skip over the derived units today because I want to do that after the quiz, and skip over density. And our lesson today is going to be on significant digits. I'm going to go through the definition of a significant digit. I'm going to show you how to determine significant digits, and then how to express your answer in the correct number of significant digits. When I see a certain term in chemistry and I look at the definition, sometimes it really doesn't make sense to me without some type of visual, and that's what I'm going to try and do for you. So significant digits, it says the certain digits in a measurement plus one uncertain digit which has been estimated. And I find that to be very confusing. It's not very clear to me what that means. So let me try and show you what significant digits are in regard to a simple picture. Let's say, for example, that we are going to react magnesium ribbon with hydrochloric acid. Well, I would need a certain length of magnesium ribbon. So let's say that this is the length of my magnesium ribbon. Chemical symbol for magnesium is capital M, little g. We'll learn more about that later, although you've probably seen that before in middle school. So now I want to measure that length of magnesium ribbon, but I want to do so in the correct number of significant digits. Now, we've already said that scientists use the metric system for measurement, and so we're going to measure the length of this with our ruler in centimeters. So I'm going to line this up, and now I'm going to make the measurement based on what I can read plus one more digit. So on the screen there, what you are seeing is this runs to that point there, and looking at it then, I think I'm going to look off the board. It's going to be easier than the paper. What I'm seeing here, and unfortunately my line's a little crooked, but that point right there appears to be just over that line right there. So when I make my measurement, I can read the 3.2, and now I need to guesstimate that last digit. And it looks like it's just over this line, so I'm going to guesstimate this at 3.21 centimeters. I was certain of this digit. I was certain of this digit. I read those off the ruler. This is the one that I was uncertain of, the one that I guesstimated. And I have 1, 2, 3 significant digits in that measurement. 2 that I was certain of, 1 that I was uncertain of. In the laboratory, you are going to be reading a graduated cylinder, and we'll be doing your first lab at the end of this week. If this is my graduated cylinder, we can look at a graduated cylinder that you're going to be using, and this graduated cylinder hope this works. Just trying to get a darker color under there so you can see better. This should work. Yeah, you can see that, yes? Okay, let me push it up. So you can see, and unfortunately it's leaning, but I think it's very legible. You can see here as you're going upward, for example, if this is the 10, you've got 11, 12, 13, 14, 15, etc. So the graduated cylinder reads to the ones place. So that means you have to record to the 10th place, 1 more digit than what you can read. So let's say, for example, that this is 10 and this is 20 and 30. And so this is going to be hard to get everything in there. I'm going to blow up this region right here. So this is going to be 20. And this is going to be 15. And this is going to be 10. And so we've got 11, 12, 13, 14, 16, 17, 18, 19. And I'll teach you how to read the graduated cylinder, but let's say, for example, this is the meniscus. When you read a graduated cylinder, you want your eye level to be at the bottom of the meniscus, and I'll re-illustrate this before we do the lab. The point we want to make here is we have 11, 12, 13, and we're going to guesstimate that last digit. It appears to be right in between, so we're going to guesstimate it at 0.5. I'm certain of the first 2 digits. I'm uncertain of the last digit. And that's what significant digits are. Now we want to learn all the rules of determining significant digits. And the rules are pretty straightforward. I think you'll find great success with this section. We want to look at the rules to determine sig figs. There are a whole series of rules listed on the left. It tells you how many digits to count. It provides you with some examples and the number of sig figs or significant digits. We usually abbreviate as sig figs. The first rule is that non-zero digits, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, are all significant digits, and therefore you count them. For example, if you have 3,279 millimeters, these are all non-zero digits. You count each one, 1, 2, 3, 4 significant figures. Same thing here, 11.2, all non-zero digits. You have 1, 2, 3 sig figs because you count everything that isn't a zero. So 1, 2, 3, 3 sig figs. So that's a pretty easy rule. And we'll be doing some examples of each one mixed together to make sure that you understand. Leading zeros. Leading zeros are zeros before an integer. So leading zeros are zeros that come prior to an integer, and you don't count them. Leading zeros are losers. You're not going to count leading zeros. So 0.0045, these zeros here I'm not able to highlight those three. So these zeros that come before an integer or to the left of the integers are not significant. We don't count them. We count the non-zeros, 1, 2, 2 sig figs. Same thing here. Leading zeros or losers, we don't count them. We have one significant figure. Leading zeros don't count. Non-zeros do. Captive zeros. When you are held captive, you are surrounded. All captive zeros are significant. So any zeros sandwiched between two integers are significant. And so we would count the non-zeros as well as the captive zeros, and we have 1, 2, 3, 4 sig figs. 6,000,008 grams. We count the non-zeros as well as the captive zeros. So we count all 7 digits here, 7 significant figures. I'm certain of the first 6, I'm uncertain of the last one by definition. Trailing zeros. If you hitch a trailer to your car, does it go in the front of the car or the back? In the back. Trailing zeros come after an integer. They are only counted if the number or quantity contains a decimal point anywhere in the quantity. So 100 hectometers, these are trailing zeros, but there's no decimal point, so they're not significant figures. 1. 100 with a point millimeters. 1, 2, 3. This time we count the trailing zeros because there's a decimal somewhere in the quantity. 100.0, there's a decimal in the quantity. Trailing zeros then all count. You have 4 significant digits. 0.0100. What kind of zeros are these first two? They're leading, so do they count? No, because leading zeros are losers. We're not going to count them as significant. Why do these 2 zeros count? Who are you? Sean.
Because they're trailing zeros and there's a decimal point.
You got it. They're trailing zeros and there's a decimal in that quantity. So therefore, we don't count the first 2, but we go 1, 2, 3. With scientific notation, if the scientific notation is written correctly, then the numbers before the time sign will count, all of them. 1, 2. 1, 2, 3. This case, scientific notation is not written properly, and so then you'd follow your usual rules. You're not going to count those leading zeros. So you would just have 1. Let's see if we can apply those rules. This part I think you'll find great success with. It's relatively straightforward. We've got 6 examples here. We want to indicate how many significant digits in each of the following quantities. 526 centimeters. How many sig figs would there be? Go ahead. 3 is correct. Very good. How come?
Because they're all non-zero digits.
You got it. Perfect. Excellent job. Who are you?
Cassandra.
Cassandra. Good job, Cassandra. Number 2. Volunteer, volunteer. Who are you? Ashley. Go ahead. 3 is correct. How come? There's so many more digits than 3. The zeros are leading, so they don't count. Excellent. All right, on number 3, how many sig figs? Sean? 5 is correct. The leading zero counts or doesn't count?
Do not.
Don't count, but you counted these trailing zeros. How come?
Because of the decimal point.
You guys are so smart. Good job. So some of you are thinking, well, why is this hard? Just wait. The best is yet to come. 25,400. How many sig figs? Who are you? Brian, go ahead. 3 is correct. You didn't count the trailing zeros because
Using decimal point.
you got it. Excellent job. All right, 25,007. Who are you?
Jenna
Jenna?
is
5 is correct. And you counted the zeros because they are? You got it. Excellent job. And on the last one, 3.25 times 10 to the 25th molecules. Go ahead.
3.
3 is correct. Easy peasy so far? Okay. We know how to determine sig figs. Now we want to learn how to express our answer when we've multiplied, divided, added, and or subtracted in the correct number of significant digits, and we also want to know how to round. So this will be the second part. We're first going to go over multiplying and dividing. It says round the calculated result to the same number of sig figs as the measurement having the least number of significant figures. Carry all numbers through and then round off. And there's a series of examples here that will work together, and there's a bunch of examples at the end that will work together, and then you'll be ready to work a whole bunch on your own, and you'll have a lot of time to do that. In the first example, we have 3.45 centimeters times 4.5555 centimeters. If I calculate that either on paper or on my calculator, I get 15.716475 centimeters squared. Remember, for the units, if you're multiplying units together, you add their exponents. So the 1 plus 1 makes 2. This would be like an area maybe of a rectangle. Now, I look at the quantities provided. This one has how many sig figs? 3 is correct. This one has how many sig figs? 5. Therefore, my answer has to be in 3 sig figs because you express it the same as the one with the least number of sig figs. So I have 15 point, the 7 is followed by a 2, so I'm just going to leave the 7, and I have, I'm sorry, the 7 is followed by a 1, which is less than 5, so I round down. So I have 15.7 centimeters squared. In the second example, I have 125.0 millimeters times, the star is times, 246 millimeters squared. In regard to the unit, I'm multiplying the imaginary 1 plus 2 gives me a cubed unit here. And now how many sig figs in 125.0? 4 is correct. The trailing 0 counts because there's a decimal. How many sig figs in 246 millimeters squared? 3. So my answer has to be in 3 because it's the least number when you multiply or divide. And this one's a little trickier. I have 30,750. I keep the first 2. I have 30. Very rarely do those change, although they can. I can show you where. And then I have a 7, which is an odd number, followed by a 5. I round the 7 to an 8, and just be very, 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 very careful. You need to replace the other 2 back spaces with zeros. If you report your answer as 308, that's 3 sig figs, but you've greatly changed the quantity. There's a big difference between paying $308 for something and $30,800 for something. So don't change the value. Make sure you replace these back digits with zeros. Unless you have a decimal point, that will change things. And all of these examples will be provided. We'll hit all the high points. Raise your hand and tell me how you think this one came about. Not sure? All right. How many sig figs in the first quantity? 5. How many sig figs in the second quantity? 2. In regard to the unit, when you divide, you subtract exponents. So 3 minus 1 is 2. So when you put it in your calculator and you divide those quantities, you get this. I have to put this in 2 sig figs. I keep the 1, the 5 is followed by a 9, so I round the 5 to a 6, and I replace these 2 digits with zeros. Now how come I didn't put the decimal point at the end?
Because then the 2 zeros would count and you'd have more than 2 sig figs.
Exactly right. Then those 2 zeros would count and you'd have 4 sig figs and you only want 2. Excellent. Okay? This one's a little bit cranky. You've got 5 sig figs, you've got 3 sig figs, and how many sig figs would our answer be expressed for this division? 3 is correct because you express it in the least number of sig figs for multiplication and division. You subtract the exponents, so now you have millimeters squared, and this is what you get in your calculator. You want it in 3 sig figs. Now that is a problem unless you go into scientific notation, because you have this and if you just tried to get it out of scientific, if you just tried to round it without scientific notation, you would have had this. But how many sig figs is that? 2. So you need, if I'm putting the decimal place here, which I would after the first integer, I've got 1, 2, 3 positions, 10 to the 3rd millimeters squared, and I did need 1.50 because I needed 3 sig figs. So sometimes you do have to go into scientific notation. So when you multiply or divide, you go to the least number of significant figures. And like I said, the trickiest part is when you have to maintain those spaces for the value, and we'll go through several of those when we do our examples. With addition and subtraction, the rule is different. You're not looking at the least number of sig figs for addition and subtraction. What you're looking for in addition and subtraction is the least number of decimal places. The answer can have no more digits to the right of the decimal point than there are in the measurement with the smallest number of significant digits to the right of the decimal point. For example, 3.45 millimeters plus 100.1 millimeters. When you add or subtract, you must have the same unit. If I'm 63 inches and Brian is 70 inches, he is 7 inches taller than I. When you add or subtract, you must have the same unit. So that's the first thing you check and you do. Here you have 2 decimal places, or to the 100th. Here you have 1 decimal place, or to the 10th. You add the 2 together and you have 103.55 millimeters. But your answer has to be to 1 decimal place, or the 10th. So you have a 5 followed by a 5. You're going to round it up to 103.6 millimeters. Now expressed with 1 decimal place, maintain that unit. Sometimes on these problems it is easier to write vertically. It's just not always easier to type. I'll show you in the next problem. You have 12, you have this on your paper, 12.4 centimeters, and from that you will subtract 2.14 centimeters. When you initially do the math, you have 10.26 centimeters. Again, you must have the same unit, which you maintain. You only want as many decimal places as in the one with the quantity with the least. So you want to the 10th place, and that then will round to 10.3 centimeters. When you add or subtract, you want the least number of decimal places. 1045.12 milligrams plus 3.2 grams. You want to express this answer in grams. Now this is tricky on multiple levels. What did I tell you about when you add or subtract? You must have the same unit, exactly. And I'm telling you which unit I want right here. I look at that quantity. That quantity is to the 10th place. My answer will be in grams, and my answer will be to the 10th place. I need to convert this quantity to grams. I do so by moving the decimal place 3 to the left, or dividing by 1,000, and that gives me 1.04512 grams. So to go from here to here, I move the decimal 3 to the left. I added 3.2 grams to that. I initially had this. My unit is grams, and I go back to the original, which is to the 10th place, and my answer's to the 10th place. So if you have 2 different units, see how I want it expressed. Look at how many decimal places that quantity has and express it accordingly. This last problem here is a little tricky, and this will start to come together as we work through many of the problems together. I have 54 centimeters plus 1.25 centimeters, and that's equal to 55.25 centimeters. I had the same unit. I added those quantities together. How many decimal places in 54 centimeters? None. How many decimal places here? 2, or to the 100th. So my answer has to be expressed to no decimal places, 55 centimeters. So when you're adding or subtracting, you go to the least number of decimal places. When you're multiplying or dividing, you go to the least number of significant digits. Okay? The last piece of the puzzle before we practice like gangbusters is rounding. And you are familiar with basic rounding rules from math. The rounding of 5s is a little bit different than what you've seen in math. and that's what we're going to focus on here. It says if the last significant digit before the 5 is odd, round up. That's what you've always learned. If the last significant digit before the 5 is even, and there are not any numbers other than 0 or zeros after the 5, do not round up. Leave it alone. For example, if I wanted to round these to 2 sig figs, I have 3.15. I want 2 sig figs, so I want it to stop there. I have an odd number followed by a 5. I round up. That's what you've always done. Here's what you've never done. If you have 3.45, you want 2 sig figs. You have an even number followed by a 5. You want to round down, 3.4. If you have an even number followed by a 5, or even if there were zeros on there, you round down. In contrast, if you have 3.451, you have an even number, and that would be the last sig fig, followed by a 5, but now you have another number other than 0, then you round up. If you had this, you'd still round up. So as soon as you put any number other than 0 after it, you're going to round up. Let's look at these. It says round each of the quantities to 3 sig figs. Let's take a look. I'll do the first one, you'll help me with the rest. I have 3355. Gonna keep the 3, gonna keep the 3. I have an odd number followed by a 5. I will round the 5 to a 6 and replace the back 5 with a 0. Let's look at this one. I have 3,165 grams. I want 3 sig figs. What do I do?
The 5 is behind an even number, so you keep the 6 the same and you change the 5 into a 0.
So I'm going to do 3160. Perfect. Excellent job. An even number followed by a 5, you leave the 6 alone, you replace the 5 with a 0. We want 3 sig figs. Volunteer, volunteer. Go ahead.
You keep the 3 and the 2, and there's an even number, then there's also a sig fig after the 5, so you're going to round it up, the 6.
And replace the other. You got it. Perfect. Excellent job. Oopsie. All right, 11,850 and 3 sig figs. Go ahead, Sean.
We would round to 11,800 because there's a 5, but the number that follows it is 0.
You got it. Even number followed by a 5, only with zeros, so you're going to round down. Perfect. That can be very tricky, especially when we mix it in with the previous. Questions at this point? All right, when you add or subtract, you go to the least number of what? Decimal places. When you multiply or divide, you go to the least number of sig figs. All right, now we are going to use what we practiced previously in some additional problems that will work together. We'll do these examples together. You'll try these problems, and if you are golden, you will have the rest of the period to practice this. This second quiz, which includes one more component that will hit Wednesday, and the quiz will be next week for the second quiz, is very tricky because of the sig fig component. It's just tricky, and you'll see why as you work through the problems, but you've had great focus, and I know you'll be highly successful with it. And I think you'll learn very quickly on in here. The more you practice, the greater the likelihood of success you'll have. All right, in that first problem, we have 2.3 centimeters plus 17 centimeters. So let's work through these problems. I'm going to work them out on paper so you have it as well. And like I said, sometimes it is easier to work some of the addition and subtraction vertically. This one really looks pretty easy, probably not necessary. 2.3 centimeters plus 17 centimeters. When you add the two, you get that. And again, when you add, make sure the unit is the same. However, when we add or subtract, we go to the least number of decimal places. This has one, this has none. So what should my answer be? $19 centimeters, right? Sig figs don't matter in terms of how many you start with, how many you finish with addition and subtraction. You're only watching decimal places. Number 2 is a little trickier. On number 2, we have 20.1 meters, and we're going to subtract from that 0.00214 kilometers. We want our answer in meters. If we want our answer in meters, we look at the quantity in meters. And how many decimal places does it have? 1. So in how many decimal places should our answer be expressed? 1. I have to convert this to meters. So I have 20.1 meters minus kilometers to meters. We're going down. We're going to move the decimal 3 to the right. And so we have 20.1 minus 2.114, and what comes out initially is 17.986 meters. But we said we wanted one decimal place. Now you have a 9 followed by an 8. You've got to round that up, and so you have to round that up, and you get 18.0 meters. Do you understand the one decimal place for the answer? Do you understand the rounding? Okay, good. You're doing really well. I would highly recommend that you work the answer out first in terms of just what comes out of the calculator, and then do the rounding. This way, if you're having issues with the rounding, expressing in sig figs, it's easy for us to find together. Let's look at 3. We've got 5.24 millimeters, and we're going to multiply that by 42,000 150 millimeters squared. So if we plug that in, we have 220,342. You've got a 1 plus 2 is millimeters cubed. Now that, of course, is not your final answer. In how many sig figs should our final answer be expressed? 3 is correct. Now that's going to be a problem, because if you do this, how many sig figs is that? 2. And if you put the decimal, you'd have 6. So this has got to go in scientific notation. You're going to pop the decimal in here, and you're going to have 3 sig figs, and then you have 1, 2, 3, 4, 5 positions to the right. So you have 10 to the 5th, and you've got the following. You want to go run that stuff off? It's all back there for you. Why don't you try 3A? Give it a shot. So 3A. How'd we do on 3A? Don't look up unless you've got it. Otherwise, give yourself another minute. Yes? Do you want to try 4 and 5 alone, or you want to do them together? How about we do You try 4, we'll do 5 together. 5's a little weird and it's that calculator issue. So you try 4, which will be back on the screen in a sec. And again, don't look up unless you finished it. I'll show the answer to 4. How do we do with 4? Got it? All right, you recognize the answer had to be in 3 sig figs, so you rounded an odd number followed by a 5 rounds up. Keep those zeros to maintain the value. And again, 3 minus 1 would be centimeters squared here. On 5, I just want to remind you of your calculator usage. Also, I believe one of you left a calculator in here the other day. I'll find it. Yeah, somebody did. This one I think came from 7th hour. I'll find it. Somebody left a TI-30 in here. In regard to this problem in your calculator, again, be careful here. You're going to punch in 3.54 EE25 divided by 1.44 EE23. And in how many sig figs do you want that answer? 3. So you would have 246. What's your unit? What's 3 divided by 3? 1. What's x divided by x? 1. What's centimeter over centimeter? 1. What's molecule over molecule? 1. So there is no unit, it cancels. Okay? And in one of our upcoming labs, you'll see that there is no unit for something you're going to be looking for. So it's a good little lesson there. When you add or subtract, you go to the least number of decimal places. When you multiply or divide, you go to the least number of sig figs. The rounding of 5s is just tricky with that even number followed by a 5 only. You round down. Questions in regard to the rules of sig figs? How to express the answer. If you keep these rules in front of you as you work through the problems, you will be highly successful. What we're going to do in the second half will be as follows. I'm going to ask you in your notes, you'll work in small groups. I'll come around. You want to work through problems 1 through 4, and this is in your notes. What you also want to work through today is quite a bit in the classwork, and we just have a ton of time, so you'll be able to get this done here. On classwork 1-1, you want to work in the significant digit section, and there are 1, 2, 3, 4, 5 sections there that you should be able to do. I believe the trickiest section for you will be the 4th. But if you can do that 4th section that has problems 1 through 20 in it, the rest of it I think is pretty simple. So basically on your classwork you should finish everything except the density and percent error section. And that's what we want to work on the second half today. Questions? Alright, so hopefully you have a better understanding of sig figs, how to express them. You'll see the importance of sig figs in every lab we do, so this will help you. Also, in regard to the factor label method, you'll now understand how to express your answers better. With your factor label method, whatever quantity you start with, you'll look at those sig figs and express it accordingly, and I'll point that out when we do some more examples there.